Cool. All right. Good afternoon or partial good afternoon to some of you folks if you're in the West Coast. West Coast about 2 o'clock in the afternoon. Welcome. This is GroupBy. I don't want to sound like I'm a radio DJ of some sort, but welcome to GroupBy. It's my first time doing, well, I think I did I think I did something for GroupBy a couple of years ago. Can't remember exactly what, but this is kind of like my first exposure to the new GroupBy and my topic for today. And hopefully you can see my screen. I will switch back and forth between my screen and my demo environment. I've got a very simple demo environment. This is all about what SQL Server DBAs need to know about Docker containers. And I specifically titled this, or rather design presentation for SQL Server DBAs. Now, you don't have to be SQL Server DBA. You could be a developer who's responsible for deploying SQL Server databases, and that's fine. The idea behind this is for you to understand how you can leverage Docker containers for deploying SQL Server. And for the DBAs out there, of course, this is something that we need to do, right? Deploying SQL Server databases. Quick introduction to who I am. My name is Edwin. I don't have my camera or my webcam with me because I wasn't really expecting to be locked down for 60 days where I am right now. Microsoft Certified Master for SQL Server. I've been focusing on high availability and disaster recovery for the past 15 years now. And the reason I shifted, not really shifted, but I started focusing on Docker containers because it's kind of like where the industry is moving into. When you think about it, you know, back then it was physical machines and virtual machines, and then now it's Docker containers, and then Kubernetes, and then what have you, whatever is up there that people would start leveraging for deploying SQL Server databases and provide high availability as well. You can connect with me on Twitter or on LinkedIn. Again, if you have any questions, type them in the chat or the Q&A window. I'm more than happy to answer those questions as we move along. I wanted to start off by really defining the key that drove all of these things. And the key there is really DevOps. It's kind of interesting. We in IT always like the idea of throwing in new stuff, like new terms like agile, you know, cloud. And most people just fall into the trap of just looking at the term, the jargon, the new shiny object, without realizing this isn't really new. And I remember doing DevOps even before it was even called DevOps. I used to be a data center engineer, and we were the cloud. We were responsible for you know, the services and the whole data center, and we've got clients. And like I said, we were the cloud. And I barely touched the keyboard when I was working as a data center engineer. I spent more time on whiteboards, with pen and paper, documenting, outlining, defining the whole process so that we can automate everything that we do. Because if we can automate things, we can easily transition from old environment to new environment, or maybe come up with more productive ways to streamline our operations. In fact, one of our key KPIs or key performance indicators back then was to reduce the amount of incidents that we are handling. And automation has played a big role in making sure that we achieve that goal. In fact, our team across Asia Pacific became the most profitable team in the whole company. And that's because we kept several principles and philosophies in mind. And again, even before it was even called DevOps, we were already doing DevOps. We don't just call it DevOps because it's a combination of philosophies, principles, practices, and tools that increases an organization's ability to deliver applications and services at a high velocity. And I took this definition from AWS because it's cool, right? The key thing here is that it's not just about the tools. Most people think that when you start looking at DevOps, they think, oh, it's just tools, right? Let's, you know, mash up all these different tools that we could use and just call ourselves DevOps. No, in fact, in our team, we have this core philosophy, this core principle that any new engineer joining the team would have automation in mind. Meaning if you haven't done any scripting or automation in the past, you need to ramp up real quick because that's how we run the business. That's how we take the business to the next level and look at how we can improve our processes. And it's really all about evolving and improving not just products, but also services at a faster pace than using traditional, practices, developments, or infrastructure management processes. At the end of the day, the way the technology is moving, we have to keep up with it. And at the same time, we need to make sure that we're providing more value to the business. And that's the whole idea behind the concept of DevOps. It's not, sure, I know how to use all of these tools. It's not about knowing how to use the tools. It's about a certain way of thinking. That's what DevOps is. And when you start looking at how Docker evolved and containers evolved, you kind of look at the different challenges. For one, we started off with physical machines. Back in the days, and I'll ask this question, you could type it in chat window if you want. How long did it take in the past for you to request for a SQL Server instance in the days of physical machines? How long? 4 weeks? 6 weeks? I don't know. In some cases, depending on how long the procurement process takes, 4 weeks on average. But that's kind of like, wait, I need to deploy the databases now. Can't wait for 4 weeks. And so that's the bigger challenge. Plus, we're guessing, which is kind of interesting when I tell the story about, hey, we're data professionals and we're guessing. What do you mean by guessing? Well, we need to deploy database A, B, and C, and we need this. What's the performance baseline? Nobody knew because this is a new deployment. So we're basically guessing the compute, the storage, and networking resources, because when we go and reach out to the hardware vendor, we need to tell them, look, give us this, because we don't know what the workload would look like. And so we buy very expensive hardware just so we can cope with future demands. That's why I call it guessing, because we don't really know, right? And that's the bigger challenge. Hence came virtualization. What we did with virtualization was we bought massively large hardware and ran as many VMs as we can. There's a reason why over-provisioning is a thing, because now, business executives are thinking, we don't want to waste time. We don't want to waste resources. Let's put as much as we can in here. In the days of the physical machines, you're buying very expensive hardware, beefy, massively powerful hardware, and you're barely using 30% of the resources. And as far as the bean counters are concerned, that's a waste of money. And so virtualization helped solve that. And now we're running massively large VMs, or rather massively large physical machines, and putting a bunch of other VMs on top of it. But there's still this challenge of, well, wait a second, now we're over provisioning. We're also needing to manage every single VM as if they're physical machines. We've transitioned from physical to virtual, yet we're doing the exact same thing. We're patching servers, we're deploying servers. Well, the deployment is a lot faster now, but we're still doing the exact same things. We're patching, we're installing updates, we're maintaining, we're monitoring, we're securing. We're not in the business of maintaining operating systems. And it's kind of like a trap that a lot of IT professionals fall into, is we are thinking, oh, I'm a sysadmin, I'm a DBA, I'm a developer. We'll write code, we'll maintain servers. No, all we're simply doing is helping grow the business in whatever capacity we can. Hence, when we come into what containers are really all about. But what problem does it solve? The main problem that containers solve is simply answering the question, wait, but it worked in my laptop. You had a performance issue, you troubleshoot the performance issue or a functionality problem, and the developer would tell you, but it worked in my laptop. Java attempted to solve this with the Java runtime environment. But the thing is, with different versions of Java, you're kind of like, you're still dependent on the runtime engine's version in making sure that your applications work the way you expect it to work. Run on different runtime engine version, you're screwed. Well, not fully, partially maybe. But the idea behind containers is to reliably run software when moved from one computing environment to another, meaning your developers can deploy SQL Server on a container, put in anything that they want in there, of course, assuming the right supported version, putting whatever it is that they need in the container, deploy that container to an on-premises Docker host, deploy it on a cloud provider, deploy it on a hosted, and it works exactly the same. That doesn't mean there's not going to be any problems, because technology is not a solution to, it's not a silver bullet. It doesn't solve everything. It's one way to solve a major problem, which is, again, making sure that whatever runs in your laptop works in production, because it's the exact same way that things have been deployed, right? And so we're trying to look at the difference between virtual machines versus containers. When you look at virtual machines, you look at your physical machine and that thin slice, that layer of hypervisor that makes everything above that layer work. And then you start creating VMs. But wait a second, I can't simply run an app, and I'm going to start referring to SQL Server as an app here. We can't run an app, or in this case, SQL Server, on a VM unless we start installing an operating system. Now, operating systems are a necessary evil. We need them. Can't get rid of them. But I just wished we don't have to deploy operating systems. And in order for me to deploy an app, I need that operating system. So when you think about it, if I deploy multiple VMs on my hypervisor, it's like duplicating operating systems, which means I need to patch it, I need to maintain it, I need to secure it, I need to monitor it, and I need to staff for it. That's man hours when you look at the amount of effort that I need to put into a VM. I mean, how much time do you spend per week maintaining the operating system when all you really need is to make sure that the app runs the way you want it to? Enter containers. With a container architecture, you have your hardware and then your operating system. And by the way, I'm going to be focusing on Linux throughout this presentation. I would love to do Windows, but I haven't really seen much of the development from Microsoft as far as SQL Server on Windows containers is concerned. So I'm going to be focusing on Linux here. So going back, with containers, you got your operating system, and then you have your container. That's it. Containers are a way to virtualize the operating system. Instead of virtualizing the hardware, we're virtualizing the operating system, which means I can now run an app on a container without having to worry about, hey, how much disk space do I need to worry about just to install the operating system. Here, we're looking at a container and then installing an app on that container, which means I can run as many containers as I want on top of the same hardware and not have to worry about maintaining operating systems, because I have one layer of the operating system that I need to keep, that I have to maintain. Plus, as far as disk resources are concerned, they're a fraction of the disk space utilization as a full-blown VM, right? So what is a container? It's a Linux concept. It's one of the reasons why you see a lot of these topics and resources on Docker containers running on Linux, because it started as a Linux concept. In fact, it's not a new thing. The idea behind virtualizing the operating system has been there as early as 1970, if I'm not mistaken. Yep, 1970. That was like a few years ago now. And because, again, just like any technology and just like any innovation, if the business couldn't find a really good use case that they can benefit from, it just stays a technology. It stays in the back burner, and until like 20, 30 years later, when somebody says, hey, this is a concept that we can revisit and apply to something that would solve the current problems of businesses. And that's why all of the concepts that you see, the commands that I'm going to use, the principles behind running containers were all built with Linux in mind. Okay, it's trying to virtualize the Linux operating system kernel. On the Windows side, of course, it's virtualizing the Windows operating system kernel. But at the end of the day, a container is simply virtualizing the operating system kernel as compared to a VM where it's virtualizing the physical hardware, right? That's a big difference. You're trying to share the host's kernel, meaning as you're virtualizing the operating system kernel, every single container will have access to the operating system as if they are running on their own operating system. But it's just a slice of the operating system, which means having access to the compute, the network, the security, the storage resources, they're all shared across the kernel. It's just sliced in a way, just like VMs where they're totally isolated. So whatever happens on one VM, or rather on one container, does not affect other containers, right? And it uses the kernel's ability to group processes for resource control. And this is very important, especially we know that SQL Server uses up a lot of memory. You want to make sure that whatever happens to that container does not impact other containers running in the same Docker host. They feel like lightweight VMs. That's why most people call them VMs 2.0 or virtualization 2.0, but they're not. They're not really virtual machines. Again, the way to think about it is with VMs, you're virtualizing the hardware. With containers, you're virtualizing the operating system kernel. Okay. Now let's have a look at the Docker architecture in general. And when you really do think about it, what is Docker? Simply put, Docker is both a technology and a company. Docker Inc., the company behind this, started off as a platform as a service company until they pivoted to becoming a software development company that now is the de facto for anything container. But they're not the only container runtime technology company out there. It's just that, just like Red Hat is for Linux or VMware is to virtualization, Docker is for container runtime environments. Okay, so how does Docker run containers? So let's see, I'm here sitting at my client workstation and running Docker commands to say Docker run, and this command will run a Docker container. What happens is the first thing that the Docker daemon or the Docker service or the Docker engine in this case does is it first checks. It's checking. Do I have an image of this container in my local storage subsystem? Is it my local disk? If it is, it will just run it. If it isn't, meaning, let's say this is the first time that you're running a container from this image, the Docker daemon would reach out, it will reach out to a Docker public repository, and in this case, or container repository, in this case, it's Docker Hub. It's the default container registry that the Docker daemon uses. Reaches out to Docker Hub, pulls the image that you are trying to run a container from, stores it in the local storage subsystem, and starts running container from that image. Okay. Once the image is already in the local storage subsystem, any succeeding runs to the container or to a container based on that image will be quick and fast, right? And you can run as many instances of containers using that single image. Of course, it's still dependent on the amount of compute, storage, and networking resources available running these containers. Let me quickly switch to my lab environment, and I do have a couple questions here. For those who may not know, there's a SQL Server Linux container, and folks can run Docker on Windows machines. That is correct. You can run SQL Server on Linux containers on Windows machines, but it's not something that I would recommend. You could do that with Docker Desktop for Windows, where it creates a Linux VM to run a Linux container on top of it. Again, I'm not going to be, I don't recommend it for production uses because the fact that you're adding another layer of abstraction on top of an already existing abstraction on the operating system. So let me switch to my demo environment real quick, and hopefully you can see my screen. Oops, and
Shows, that's okay. You stop sharing there for a second. We'll see.
all right. I'll just share my screen there. So hopefully you can see my screen.
There we
now.
go. Yeah, works perfect.
So what you're seeing here is my Windows 10 workstation, and I'm connecting to a remote Docker host. It's a Linux CentOS 7. I can't remember exactly what version I'm using. And it's Linux. If you want to start working with Docker containers, I highly recommend that you start getting familiar with Linux commands. Even with PowerShell, the Docker for Windows leverages both PowerShell and command line, but it's more beneficial for you to leverage PowerShell. So you can take advantage of all the PowerShell capabilities, and then you use that together with Docker. Now, going back to what I was mentioning earlier about how Docker runs containers, let me just quickly run a very simple command. And it's Docker's version of Hello World. And what's really interesting about this is, it's unlike how most people or most technologies use Hello World, or how most programming languages do Hello World. Docker has this really unique approach to displaying and showcasing Hello World by highlighting how Docker runs containers. And the container simply does one thing. It displays this text and it exits. And if you look at the steps and the output of this, I'll work on some of these sections over here. First thing that Docker does is, if you run a command like this, it would check, does this image, this Hello World image that this guy's trying to run, does this image exist in the local storage subsystem, meaning a local disk? If it doesn't, well, it will start pulling from a Docker container registry, which stores all of these images that Docker can use as an image. And it will pull that image down to the Docker host's local repository, or in this case, the local disk, and then we'll use that to run an image. Downloaded your image for Hello World latest, and then runs it. Running the image, rather running the container from the image, displays this, and it shows you exactly what I just did. Client contacted Docker daemon, Docker pulled the Hello World image from the Docker hub, Docker daemon created a new container, and then ran it. Now here's the thing. Containers are meant to run apps. And like I said earlier, I'll start calling SQL Server as an app here. If the app completes what it's supposed to do, it exits and the container terminates. But wait a second, we can't do that with SQL Server. It's a service. Hence why you're running SQL Server as a daemon inside a container, and it will run so that you could keep running the SQL Server instance and access the databases inside it. In this case, because the app, in this case, the Hello World app, completes what it needs to do and exits, so does the container. If we run Docker PS, commands in Docker are composed of Docker the main command and the subcommands. In this case, Docker is the main command, and then PS is a subcommand. PS is just to list all the running Docker processes, or in this case, running containers. If you look closely, I've got nothing. Nothing. Why? Because the container exited the minute that it completes its work. Okay, and we can explore a lot of these commands as well. So say, for instance, I want to display all the containers in my Docker host, regardless of whether they're running or not. In this case, I've got the Hello World container that I ran a couple of minutes ago that exited. So now if I decide to run the exact same command It wouldn't have to pull down the image because it's already in the local storage subsystem. Doop, done, quick, fast. Imagine how long would it take to start a SQL Server on Linux container once the image has been pulled onto the local repository. Okay, let's explore some of the commands. For instance, if I want to do a search, now I can go and explore the Docker Hub. This is the default container repository that Docker engine would use. And I could search for SQL Server. And whenever you're running an image or pulling an image using Docker commands, what this is basically doing is going out into the Docker Hub, searching for that keyword that you're searching for and displaying all of that. So why don't we try using the command line instead of relying on the Docker Hub? Say Docker search. And I want to display all of the images that Microsoft has displayed on Docker Hub. Reached out to Docker Hub and queried the image registry for all of those images that Microsoft has already provided. .NET Framework, SQL Server on Linux, and so on and so forth, which is basically this. When you look at the Docker Hub's definition for the SQL Server on Linux images. And it's also interesting that this is actually redirecting the contents from Microsoft's own container registry, MCR, or Microsoft Container Registry. Okay, there are a couple of ways for you to pull an image, either pull an image from Docker Hub or from a repository, an image registry that hosts it. In this case, you can pull the SQL Server on Linux images from Microsoft's own container registry. Okay, if I want to search for specific SQL Server related images, because again, this is all about SQL Server. I don't really care about .NET. I don't want to go back and do .NET again. I could simply pipe the results of that command into a Linux command called grep and then just use the SQL keyword. And I'm only concerned about SQL Server container, rather images. So I'm looking at the SQL Server on Linux, the SQL Server on Windows image, SQL Server on Windows running Express editions, and then the MS SQL tools. Okay. Instead of me going through Docker Hub, I can do that from within the command line. I can also explore a lot of these commands because let's say I wanted to know more about the other commands. I could do a Docker help. Let's say earlier we did a Docker run command and then type help to display all of the parameters that I can pass when running this specific command. And every single one of those subcommands, you could easily pull up the help files, the parameter usage for every single one of those. Kind of like the man pages that Linux used to refer to. I no longer rely on man pages because we can use Google for just about anything. Okay, so let's say, for instance, I wanted to work with SQL Server on Linux images because I'm running on Linux. So I want to use SQL Server on Linux images. I could either pull the images first and store them in my local repository or just run them. Okay, so let's have a look at this and maybe pull specific images based on the tags. I want to pull, I'm just gonna take a stab at CU5. Okay, CU5, and I want to pull that image, specific image. Docker pull, and I'm building commands as I go. Docker pull, I want to pull that image, and I want to use that specific version of SQL Server. If I can find the right, there. And building it. So what this is simply doing is I want to pull a SQL Server 2017 with CU5 image from the Microsoft Container Registry. Let's do that. And all this simply does is it is pulling that image. Now, I only did this to showcase how you can initially pull the images and store them on your local subsystem or local storage subsystem so that anytime you want to run a container based on that image, it'll be quick and fast. Now, while I'm waiting for this, I want to go back to talking about the difference between images and containers. I mentioned image and I mentioned containers as we were having this conversation about containers. What is the difference? I kind of look at images as the read-only template for creating application containers. When you think about this, let's use virtualization as an analogy. You can look at images as your golden VM template. You store, install everything in that machine, and then you sysprep it if you're using Windows. And then once you want to build a new machine, you can use that template as a starting point for creating new VMs. Let's take that a step further. And let's say, oh, I want to minimize the usage of disk space whenever I build a new VM. You can create a differential disk on Hyper-V and use that as a starting point, meaning I can create new VMs, but I don't have to copy the exact same golden image. All I have to do is build a differential disk or a layer, file system layer that I could modify, but will definitely not touch the golden image. Containers, on the other hand, are a runtime instance of an image. So when you run a container, it is based off an existing image. I'll use an object-oriented programming analogy. You can look at images as classes, while containers as objects. Classes remain the same, properties, attributes, events, methods, they're all the same. They're not going to change. When you want to create a new object based on that class, you can start modifying the properties, methods, events, what have you, override them without affecting the base class. Okay, and that's the difference between images and containers. As we start working on containers, you could, number one, use publicly available images from Microsoft. As what you saw here, you got your SQL Server 2017 with the appropriate cumulative updates. You could use the latest ones, or, well, if you're not happy with this, you can build your own. What do I mean by that? Well, all of the ones that are publicly available, plus the ones that Microsoft started releasing way back in SQL Server 2017, were running off of Ubuntu Linux. I'm a bit biased. I'd rather be running on Red Hat because for enterprise deployments, I would rather choose Red Hat for deployments. So I can build my own image, my custom image, put everything that I need in there, and only the ones that I need, because the ones that Microsoft provides contain the SQL Server tools with it. Oh, there's nothing wrong, because they're not as big as SQL Server Management Studio, but I want to keep my images, even my VMs, I want to keep them lean. I don't want to install anything. I don't want to run anything other than what I need to run. Create that and use that as my custom image that I can use to run containers on top of, okay? And images are just a set of files structured in a file system layer. This file system layer is what makes up the entire image. Think of an image as Lego pieces. I want to take 5 Lego pieces, put them together, and I have an image, which means each Lego piece is independent of the other. But in order for me to come up with a really good, really fancy Lego structure, I'll use these Lego pieces put them together to come up with a really nice Lego structure. That's what an image is. It contains application files, operating system dependent files like libraries, metadata, and everything, and then you're trying to piece them together. When you looked at what I did when I started pulling the SQL Server 2017 with CU5, I think, CU5 image from the Microsoft Container Registry, you started seeing pull complete, and hopefully everything's done now. There you go, pull complete, pull complete. What do these pull complete messages mean? The pull complete messages are actually the file system layers that make up the entire image. So for instance, we look at the hex values of, not hex, but the GUID values. The lowest layer could be the A9, DCA, 2F, whatever. And this is the foundational layer. What do I mean by that? Well, if you really think about a SQL Server 2000 and even Windows, if you look at the SQL Server 2017 with CU5 versus CU4 versus CU14 versus CU20, the lowest layer looks exactly the same on all images. And this is what the lowest image looks like. It contains the base image that everybody shares, which means as far as Microsoft is concerned, or as far as I'm concerned, if I'm building a new SQL Server 2017 with CU15, I don't have to recreate the lowest image. I'll just reuse that, the base image, like a Lego piece, use that, and piece it together with the other layers on top of it. Similarly, like the layer on top relies on the layer at the bottom, and so on and so forth, okay? So when you think about these image layers, I kind of use the analogy of, projectors in the 80s. Oh, I don't miss those days when you see those clear, transparent sheets where where you could either write on them with markers or print something out of them. And what you could think of when it comes to those transparencies and those projectors in the good old days is I can put the base image, rather the base transparency sheet with, let's say, number 1. And then I'll put something on top, which is another layer of the transparency, and put 2, and then come up with another layer, number 3. If I look at the top, I can read 1, 2, 3. For me, as far as I'm concerned, if I'm looking at it from the top, it looks like one image with 1, 2, 3 written on it. But in reality, there are layers pieced together that makes up that image. And that's what an image, a Docker image, really is. At build time, the Docker engine pieces all of these file system layers together and then locks them with the metadata so that whenever somebody pulls an image of SQL Server 2017 with CU14, this is exactly how it looked like based on the metadata. If somebody builds SQL Server 2017 with CU20, it will take whatever it is that's common between CU14 and CU20. It reuses the exact same layers that CU14 has and just build on top of it. This is what a Docker image looks like. A container, like I said, because your image is a read-only template, wait a second. If I'm running SQL Server, I'm inserting, updating data in my databases. How can I do that if the underlying base image is read-only? A container is simply introducing a read-write layer on top of your base image. The read-write layer is where the container stores every modification. So say, for instance, you have an image of a SQL Server 2017 CU14 with master database, and you want to run a container off of it. First thing that you do, you insert a new login, or you create a new login. What Docker would do is it will create a copy of the master database from the base image, stores it on the read-write layer, and that's where all of the changes will start happening. It's not going to happen on the base layer because that's a read-only template, a read-only image. And so the read-write is going to happen on that read-write layer, okay? And that's the thing about this, because you can run multiple containers based on the same image, and only the read-write layer gets created. They all point back to the layered image, the file system layer that contains, rather the base image that contains the file system layer. Now going back to this, I'm done. I've pulled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 layers for CU5. I want to display all of the images that I have on my Docker host. And of course, this includes the hello world image that I have pulled a couple minutes ago. 13 bytes, that's interesting, 13 bytes. If you look at the sizes of these, largest one is 1.46. That is way smaller than how a VM would look like. Your VM would probably be around 10 gigs or 15 gigs if you're looking at a SQL, well, if you're looking at a SQL Server on Linux VM, that's roughly around 5 to 6 gigs of disk space. Here, we're talking about 1.46 gigs, not a full-blown VM. So I can now run a container based on this image, okay? Let's use, well, let's use the latest one. I'll use this. Let's create a container and run a container based on that image. And I want to make sure that I'm running a the right image. And I want to explain the commands that I use here. Docker run. I want to run a container. -E is for environment variables. Of course, we all know the thing that we always read before we install SQL Server, the end user license agreement, as a password, the sysadmin password -p. I want to map the port on the container to the port on the host. So it's like, oh, I'm connecting to a normal SQL Server instance. -name. I want to name the container because otherwise Docker will create really meaningful names that I knew nothing about, like ecstatic Satoshi, pedantic Holden. I don't know how they came up with the names. Oh, I do know how they came up with the names. There's a GitHub repo that showcases the code built on this. It's a combination of names from famous either mathematicians, scientists, and some random keywords. It's on GitHub. It's a link. I think it's a link that I've included in my book. But the thing is, if you don't name your images properly, they would end up with ecstatic Satoshi. So if you're trying to manage containers and you don't know exactly what it's named, it's kind of hard to figure out, especially if you're running like hundreds of containers simultaneously on a Docker host. So that's why I name them. Okay. -D, I want to run it in detached mode, meaning I want to run it as a background process, like a SQL Server service. Right? -H, because developers like hard coding host names in connection strings. No. -H for a host name, and again, I'm not really kidding when I said that, because developers hard code connection strings, and if I want to make sure that I'm using the exact same server name as far as they're concerned, I mean the application connection string is concerned, I will use the -H. Otherwise, I'll just have it generate a random host name. And then I'm going to be using this image, Microsoft MS SQL Server -Linux, which happens to be this. So I'm going to be using this image. Okay. Oops. Remember, I asked the question earlier, how long does it take for you to spin up a new SQL Server instance in the virtualization days? How long does it take for you to spin up a new SQL Server instance? 5 minutes, 10 minutes? I don't really know, but depending on how much resources you have, or in the physical world, the physical machine world takes longer. Here, it's up and running. Yep, the minute that you see that GUID value, it means that the image is up and running. Yep, 11 seconds, it's up and running. Of course, I don't really know if it's really up and running. So let's connect through remote, let's initiate a remote connection using SQL Server Management Studio or your favorite SQL Server client application and check if it is indeed connected, started, running, right? I can't claim that it's running until I can actually connect to it. IPADDR is what I need to grab my IP address, because I don't have this in my DNS. Run it using SQL Server authentication, using password that I provided, and connect. And of course, part of that is checking ping 172.17.153.186. Connecting. And you could also check. I've already ran my SQL Server on Linux container. I can look at the logs to see what is going on with my container. And what you're seeing here is literally a SQL Server error log. One of the reasons why it's taking time is because it's actually doing an upgrade. If you look at this, database master running upgrade step from 862 to 863, that's why it's taking a lot longer than expected. Connect. Let's see what else is going on. We run transaction. So it does take a while for the whole upgrade process. The question here is, from Keith was, can I use Windows authentication in SQL Server? The answer to that is, number one, yes, if you're using Windows SQL Server on Windows. It's just a matter of having that support built in. They haven't built in Active Directory, official support for Active Directory authentication with SQL Server on Windows. On Linux, it's a little bit challenging on Linux, because in order for you to get your SQL Server on Linux authenticated using Active Directory or Windows authentication, you got to have LDAP configured for your Linux machine to connect to Active Directory. Plus, how do you deal with creating a new computer object? How do you deal with, rather, creating a new computer object when you run the computer or a container, and then removing the computer object in Active Directory when you delete the computer or the image or the container, okay? It's one of those things that hasn't been fully supported as far as Microsoft's concerned. The support story around that running and managing SQL Server on Linux with Active Directory or Windows authentication on a container is something that is still in the conversation. But if you're simply running, whether it's a virtual machine or a physical machine, and use Windows authentication and SQL Server on Linux, you can. Okay. Let's see. Oh, must be something wrong in this. A couple of questions here as well.
Yeah.
Corey was asking, would you be able to say, have a copy of a production database out on network share and create a new SQL container where you can get a copy of that database and attach it to a new SQL container? Maybe even copy it down locally, so say a developer could have local SQL test box for their own purpose. The thing about this, in fact, this is a segue to a topic that I'm going to cover in a few minutes, is the concept of Docker volumes. Docker volumes is simply just an implementation that we know in Windows as mount points. It's what every cloud provider implements, where you have compute and storage separately. You have your VMs as your compute. You have your storage on Azure Blob Storage or any remote storage that you could think of, whether you're running on AWS, GCP, or Azure. The idea is you're separating the compute from the storage, right? And the thing about having the storage and the compute completely independent of each other is exactly why Microsoft introduced the concept of, I think it's in SQL Server 2012. Microsoft introduced the concept of running your MDF and your NDF and LDF file rather on an SMB file share. The concept behind it is you are separating your compute from your storage, so you can store your database files on an SMB file share or a network file share, and your compute running on a VM, or in this case a container, and then just map it. The challenge there, and I'm looking at it from both a Windows and a Linux point of view. The challenge there is, number one, permissions. Okay, permissions. What about permissions? Permissions in the case of, I want to make sure that the SQL Server service can access those file shares. I want to make sure that when I start my SQL Server service and it will connect to the file share, the SQL Server service has permissions to take a hold of those files and have an exclusive block on those files. It's no different from, from you moving database files around, and all of a sudden you move from C to D, and then all of a sudden your SQL Server service can't access the database files. Okay, that's the bigger challenge there. I'm kind of wondering what is wrong with this. I'll just kill it. Docker ps or docker stop is one way to stop the container, and then docker rm is to remove the container. And every once in a while, I still mix, Linux and Windows commands from within the command line. I'm just going to use a new image. Instead, I'll use images. I'll use CU13 and run CU13 instead of this one. And this. And run a new container, and done. Docker logs, because I want to take a look at what's happening under the covers, and where I go, the upgrade process is running. There, we could connect to it, hopefully. Upgrade step, default language, LCID. Let's keep track of what's going on after this. So recovery is complete. And this is one example of how, when you're dealing with images, part of it is referring to the base image that contains, the system databases. And because you're running a new container that contains file system layers on top of it, where the top layers contain updates to the base one. Let's assume that the base one is your RTM copy, and then all succeeding file system layers on top of it contain changes to the new one. You can start looking at the topmost, having the upgrade scripts to update the database files, the binaries, and that's why you see a lot of these messages from database running in upgrade step, and so on and so forth. Corey's question, how does Docker compare to, say, Redgate SQL clone? Those are two different things, two different tools that perform two different tasks. Redgate SQL clone is cloning the database. What we're simply using Docker for is deploying a new SQL Server instance. Okay, we're deploying a new SQL Server instance, which may or may not contain databases from your production environment or your test environment. And a couple of questions here as well. Oh yeah, that's kind of like the question that was asked earlier. Let's see. It seems like the image is corrupted, because now I can't even do this. cancel, docker stop, docker rm, just to remove the image and then rerun it and see what goes on. And while we're waiting for that, let me just go back to this. I mentioned earlier that you could create your own custom images because you might not like the custom image, or rather the images that Microsoft provides. Maybe it's, again, like me, I prefer running SQL Server on Linux in CentOS or Red Hat versus Ubuntu. You have the option to create your own custom image based on how you want your operating system, the version of SQL Server that you want to run on, what CUs are there, and then use that as your kind of like golden image, okay? The way you do this is by using what is called a Docker file. The Docker file is kind of like the recipe for building a custom image, okay? A Docker file is simply a file, a text file, which is kind of weird because they have to be called Docker file, uppercase D, no extension, and one word. It's simply a text document, like I said, where it contains all of the commands that a user could run on the command line to create a custom image. Okay, so we'll explore a simple Docker file. So the first one describes the base image, and it's usually the starting point of the image, meaning it contains the base operating system. Now, this is not a full copy of the operating system. It's just the difference between what the host runs and whatever distribution that you want to run. So say, for instance, running CentOS as my operating system, my Docker host operating system, and this could be an Ubuntu image that I want to use as the basis for my SQL Server on Linux. In this case, I want to run it off of a CentOS 7.6, and because this image isn't available yet, assuming it's not available yet on your Docker host, it's going to pull that image, store it in the local storage subsystem, and builds the image based on this base image. So this is your first layer. Second layer, well, it's just label. Good practice is for you to label and get your image as detailed as you possibly can for people who need to use it. Like what name it is, what version it is, what's the operating system, is it going to be used for production, and whoever gets the phone call at 3 o'clock in the morning when somebody goes wrong with a container. Okay. Good practice, it's kind of like partially documenting the image. Okay. Next, we do 2 commands. Curl is simply pulling the SQL Server repo, meaning the metadata definition of where the underlying operating system would pull the SQL Server binary so that it can install it from there. Typically, this points to the SQL Server 2017 or the SQL Server 2019 repo that also contains pointers to where the binaries are for SQL Server and all the other dependencies as well. You can think of a repo file like you know, the metadata definition on your iPhone. If I want to install an app, it doesn't ask you, where do you want to download this app? It just does, pulls the app, downloads, and installs, right? The next run command is installing SQL Server on Linux with a -y because I want to automate this. I don't want to answer, do you agree? Yes or no? Do you? I don't want to answer that. I want it to be automatically installed, and that's why I'm passing it the -y parameter. The next line here, environment path is equal to the dollar and then the path. It is, I'm simply telling the Docker file, hey, anything that I run, commands that are run after this line, I want you to look in this path first. It's like, I want to define C program files, Microsoft SQL Server, but I don't want to type it long. So I'll create an environment variable so that any command that I would refer to after this line, I don't have to type the long C program files, Microsoft SQL Server. Next one is I want to create a new directory called var opt MS SQL data. Think of this as the default data directory for SQL Server on Windows like C program files, Microsoft SQL Server, and then the data folder. I would then, the next run command, I would then assign permissions to the SQL MS SQL user and group that they would own both the MS SQL folder and the etc password folder. I only want my SQL Server account, the one that would run the SQL Server service or the daemon on Linux, to have access to these folders. Expose is just one way of telling the developers, look, SQL Server is listening on 1433, right? You can afford not to have it because by default it will listen on 1433. Again, it's just telling whoever's going to use this which port number is this container going to be listening on, and then finally running SQL ser vr, which is the binary, the Linux binary, similar to the SQL Server.exe on Windows. And because I've already defined the environment variable, I simply just tell it, look, this is the command. It will look at opt msql bin and look for that binary inside that directory. How I create that image, I just use the docker build command, pass it the tag. In this case, I'm going to call it SQL 2017 CentOS : version 1.0. Okay, and I'm going to use the dot to refer to the current directory where the Docker file is stored, which means I'm going to be running this command in the same directory as where the Docker file is stored. I could use, I could manually provide the path if I want to, but again, it's a preference thing. So let's have a look at how, I'll give up on this. I'll go back to this, see clear. I'll remove this, and then I'll just create a new one. Docker ps, good. I have in here a very simple Docker file. Docker file. I'll open it up with Notepad. And it looks exactly what you saw in the slide. Every single one of these looks exactly the same. So here's what I'm going to do. I am going to copy this over to my Linux machine and then build a custom SQL Server on Linux image using CentOS instead of Ubuntu. But I'm currently under my home directory. So I'm going to go to cd tmp ls-l. I'm going to create a new one. Oh, I've got docker build. Docker build ls-l. Okay, Docker file. If you look at the Docker file here, cat Docker file, looks exactly what you saw from that text file. It's exactly the same. Okay, and I use WinSCP to copy files over from my Windows machine to my Linux machine. Like I can, copy from here, and let's say, oops, a Docker file, and yes. Okay, and now I can navigate through there and build that image. Docker build. And build that image. If you look at the different steps, by the way, step number 1, I already had the CentOS 7.6.1810 on my local storage, so I didn't have to pull that. And then the labels, and then here it starts looking at pulling the repo file. Oh, internet issues. Ping. Just want to make sure I have access to the internet. Perfect. And rerun it. Okay. It's pulling the repo file from this remote location, store it in a local file system, and then builds on top of builds on top of that. And let's have a look at the Docker file as well while we're doing that. After this is complete, it will then run the install process, or the install process for installing SQL Server on Linux. Come on. That is interesting. Because sometimes it's an internet connection issue. Better yet, sudo. Okay. Let's do that again. So it's an internet connection issue inside the image as it's building. By the way, while I'm working through this, because I know this is going to fail, if you look at the different steps, step number 1, using cache, what this is doing is it's actually building a container to create this layer. It's building this container to build this layer. So even when it's even when you're building your own custom image, it is creating a container, making modifications to that container, and then persisting that change as a new file system layer and building on top of it. In fact, if you explore, I'm just going to use image ID here. If you explore the image, right? If we explore the image CU10 and look at this, these are different file system layer metadata that this image contains. And let's have a look at the structure. This is the tag, and this is my host name. Of course, the host name doesn't really matter because this is a random host name generated by the Docker container as you build it. And then the command that this image, that the container will run when you build it off of this image. And then the labels based on what you saw. And then Docker version. And what else? The file system layers. These are the different file system layers that make up that entire image. Okay. In fact, Docker image inspect. Oops. Clear. When you look at, let's just run a simple container. Let's run the Docker world container just so we have something to work with. Or this. And let's grab this Docker inspect. It will tell you the container that, the port number that the container uses when you run it. And there's a whole bunch of other information like the IP address, internal IP address, because the external IP address is the one that I'm using to connect to it. What else? All the other metadata that describes the container, just like what we did with the Docker file. Okay? And this is how you create your custom Docker image based on creating your own Docker file using the version of SQL Server that you want to use. Again, assuming that it is supported. Only 2017 and higher are currently supported on containers. With SQL Server 2016 on Windows, you can run SQL Server 2016 on Windows containers because that's technically still supported as far as product support is concerned. Okay, and then include all of the commands and parameters that you need in order to run the container. Okay. I've actually written a 6-part series article on MS SQL tips on this, and you could access, the codes that I've used, the examples that I used, in-depth coverage of, how databases are stored on the read-write layer, how the images are pulled from the Docker Hub, how SQL Server, or rather how Docker leverages those images, and they're all available on MS SQL tips.
Hey, Edwin, do you want to drop that link into the chat right now?
Sure.
Oops.
Let me quickly grab that link.
So was I understanding it right? It was telling you that you had a internet connection issue while you're broadcasting live on the internet?
No, it's because it's a VM. And so what I did with that image is it's connecting through a virtual router. I don't expose I don't expose my VMs directly to the internet. So I use a virtual router to do that. A couple of questions I'm seeing. Oops. Should have sent it to all attendees. There we are.
There you go.
I'm looking at if there are other questions on the chat window.
There's one on SQL Docker, comparing that to Redgate SQL clone. Did you already answer that one?
Yes, I did.
Okay, sorry, I missed that part.
That's fine. Containers, like I said, containers is just one piece of the whole DevOps thing. It's just a tool. The more important thing here is knowing the different pieces, like cultural thing, your team dynamics. It's just one piece of the puzzle. It makes DevOps easier, but it's not DevOps in general, right? It's the idea behind this is making sure that whenever you're introducing a new tool, it's in sync with what the whole team uses, the whole team culture and team dynamics, because that's what makes things work, not the tools. You're still very important. Your role is still very important. That's why you have to always think about how can we really leverage this to improve our processes, right? I was privileged enough to be a part of a project, well, until I decided to write an entire book on it. SQL Server DBAs Guide to Docker Containers. The thing about this is most of the resources out there are mostly geared towards developers and mostly geared towards stateless applications, web applications, APIs that don't necessarily store data. There's not a lot of resources out there that are specifically geared towards stateful applications like SQL Server or even relational databases. And there's nothing out there that's specifically on SQL Server. Bob Ward's book, SQL Server 2017, Pro SQL Server on Linux, has a chapter on this. And it's actually a great resource. But the thing is, you need to approach looking at SQL Server, taking everything you know about SQL Server and leveraging your knowledge, your skills about SQL Server and moving into Docker with it. A question that I get asked all the time is, well, what about Docker volume? Somebody asked the question about what if we could present the database files from a file share to a Docker container? And because any container can have access to that file, does that mean I can have multiple containers accessing the same file share and accessing the same data files or database files? Absolutely, you can do that. But again, from a database point of view, or from a SQL Server point of view, that's a recipe for data corruption. Because what you're trying to do is you're trying to have multiple SQL Server processes take exclusive lock on the data files and have control over it, okay? While a lot of the Docker resources out there will tell you, yeah, it works. You can have multiple containers accessing the same Docker volumes or the same Docker, the same network file share. That's good for web applications that are only writing logs. on those shared drives or on the shared folders, but not for SQL Server, right? It's again, it's what you know about SQL Server, the skills, the learnings from what you know about SQL Server, they don't go away. They're just brought into a new platform that you can leverage for deploying SQL Server, whether it's on Linux or Windows, on containers. Corey asked a question. I was curious if there has been any positive or negative effects on the parent company that owned Docker being bought over by another company. Yeah, it's interesting that you asked that question. I may be a geek, but I also follow how businesses operate. In fact, the history behind Docker Inc. was that they were losing a lot of money as a platform, as a service company, until they decided, hey, let's just create something that we could sell. Let's just create something that we could turn around, make it a product. And they succeeded. That's why we have Docker. That's why we have the Docker the container runtime environment. But the thing is, again, it's in order for a company to survive, they have to have a really good business model. In fact, one of the reasons why I no longer talk about Docker Swarm, which is the clustering technology that Docker has, is because this division that Docker Inc. has been bought over by a totally different company. So now they're standardizing on Kubernetes as compared to Docker Swarm. So when you think about it, all the investments that experts made on learning, deploying, architecting on Docker Swarm is not going to go away because, for one, the company that bought over that division of Docker Inc. will now start deploying Docker on Kubernetes versus Docker on Docker Swarm. Okay. JD was asking, is there a Kindle version of the book? You can pre-order the book. I just got word from A-Press that they will start the process of printing it, and you can pre-order the book. And yes, there will be a Kindle version of this book. And my email, my Twitter, my LinkedIn contacts are there. But again, if you want to have, if you want to pre-order a copy of the book as early as now, you can do so on Amazon. David has a question. Any special considerations for running SQL Server on Docker Kubernetes? First off, that's a very loaded question. I want to differentiate Docker and Kubernetes. Docker is a container runtime engine. Kubernetes is a container orchestration engine. Two different things, okay? Docker is what allows containers to run. Kubernetes is what allows containers to work together. What do I mean by that? Kubernetes can use any container runtime environment, although they prefer using Docker as their container runtime environment. And I'm going to use SQL Server as a use case here. In a deployment like an always-on availability group where you have more than one SQL Server instance, more than one, because it doesn't really make sense to orchestrate a SQL Server instance that's running on a single container, right? Although in some cases it does make sense if you want to provide high availability. But let's say you're working with an infrastructure like always-on availability groups. And I like talking about always-on availability groups because it's, I've spent a lot of years, mastering it. If you're running if you're deploying a SQL Server always-on availability groups, chances are you have 2 or more SQL Server replicas. And in order for you to make that work, you got to make sure, wait, am I running these replicas on the same host? Or do I need to spread them out across multiple hosts, just like affinity or anti-affinity with virtualization? I can't have both replicas running on the same host because if that host dies, I'm toast. There's no high availability. And so Kubernetes is the one taking care of making sure that the replicas are running on different hosts. Plus, if one of the replica dies and you define that the ideal architecture, and this goes back to the concept of desired state. My desired state should be always 2 replicas, not 1. If one of the replica dies for whatever reason, there's no resurrecting, there's no fixing, nothing. What Kubernetes will do is it will spin up a new container, add it to that infrastructure, and making the desired state or meeting the desired state of running 2 replicas at any given point in time. So there's no 3 o'clock in the morning call where your availability group replica died and you have to fix it. No, the cluster, Kubernetes cluster is already doing that on your behalf. And that's why, like I said, I started moving towards this direction, because at the end of the day, whatever it is that I've been doing for high availability, for clustering, FCI, AG, that's going to go away because Kubernetes is going to take care of what I'm doing. So either I, ignore the fact that somebody else or something else will eventually take care of what I'm doing, or move towards the direction of making sure that whatever is taking care of what I'm already doing, I know exactly how it's done, and architect how that infrastructure would look like to provide higher availability to SQL Server instances. And like I said, that's a kind of a loaded question when it comes to defining what Docker is versus what Kubernetes is. I can run SQL Server on Docker without Kubernetes. But if I want orchestration, I want to provide higher availability, then I would move into running SQL Server on containers in a Kubernetes cluster. Corey was asking, how long do you think it might be before people start using Docker containers and SQL Server for production instances? You'll be surprised. I used to think that it would take longer for customers to start deploying SQL Server on containers in production environment. Here's the reality. And I wish I was wrong, but I started seeing a lot of my customers where, because the developers are now taking over, the whole DevOps thing, the developers are deploying SQL Server without the DBAs knowing, which means sooner or later, the developers will start taking over the role of DBAs, even when they don't even have a clue about how SQL Server works. And that's just a fact. So now they're moving from dev test to now production, and the developers are taking over. The DBAs are not aware of it, but they now have to support SQL Server on containers running in production because, number one, they're not aware of it, and number two, they're not prepared for it. So yes, it's already starting. And we may not be aware of it, but the developers are already doing it on our behalf. Next thing you know, they'll take care of, they'll take over the jobs of the DBAs because they can do it. Doesn't really matter if they know what they're doing as far as, the executives are concerned. They're doing it. So we don't need the DBAs anymore. So it's at the risk of the company, if Corey was asking, default blame acceptor. Yes, it's still relevant today, where the developers are really taking over our jobs, and it's at the detriment of the DBA, and it's at the detriment of the company, because you know what happens when you deploy SQL Server wrongly? You see a lot of performance issues, you see a lot of availability issues. Every once in a while, I still get called in to fix an outage because somebody deployed an availability group and they knew nothing about available clustering nor availability groups and how to tweak it. So it is already happening. Question is, do we want to be a part of that? Or do we want to just take a step back and let the developers do their thing, right? JD was asking, saying yes, and they call you to clean up the mess. I wish that would be the case in a few years, but if you're no longer there, I'm pretty sure they're not going to call you, even if there's a mess. And like I said, this is where I come in and I tell people, look, it's time to step up. As DBAs, as people who are in charge of taking care of SQL Server, let's not just think about the database engine. Let's think about the future of the company if they start deploying SQL Server the way it's not supposed to be deployed. If they misconfigured, if they just deployed it on containers and not even consider high availability and data consistency, and somebody might decide, hey, there's a volume out there and there's databases in there, let me just run a container and attach those. Welcome corruption. Or they blame the mess on you. True. Like I said, the reality is it's already happening. Either we get on board and take charge, or we risk losing our jobs because we didn't get caught up with what the developers are already doing. The developers are light years ahead of us. That's one thing I've realized talking to customers and working with them. They're light years ahead of us. It's just a matter of whether or not we want to take back what's rightfully ours, and that's the database platform. David has a question. How would you handle packaging multiple containers as an app version versus app plus database? This goes back to how you would deploy your applications. Now think of it this way. And in the book, I had a chapter on multi-container apps where you have a front end, a middle tier, and a database. So you're looking at 3 layers, which means either 3 or more containers. And this is where microservices come in. You're breaking down applications in microservices or modules that you could build separately and then combine, just like Lego pieces. And then when you deploy that, you start building a Docker file, not just specifically for the image that you're building, but for the entire stack. And this is also where Docker Compose come in. Although Docker Compose is mostly for developers, but you can either use Docker Compose or in the infrastructure side of things, multi-build Docker file, where you could combine, or multi-stage build Docker file, where you can combine multiple images being built in a single Docker file, and then eventually rolling out the entire stack from the front end, the middle tier, to the database layer, all through containers using either a Docker file or whatever it is used for deploying these containers. Okay. And that is all I have for this. Again, you can already pre-order a copy of the SQL Server DBAs Guide to Docker Containers on Amazon. It's already available. In fact, I was surprised when I saw this back in February, like, we're not done yet. We just finished, I just finished writing the book 2 months ago, and I already saw it on Amazon, right? Again, connect with me on LinkedIn, on Twitter, and if you have any questions, follow-up questions, I'm more than happy to answer those. And if you want to switch streams, by the way, you have the link, the Zoom link, if you want to switch streams from here to the other one. Again, thanks a lot for joining in this afternoon. Enjoy the rest of your day. If you have any questions, I'm going to stick around to answer those questions.
Edwin, thank you so much for that all-star session. That was amazing. What an end to a fabulous track over here on the dev stream. Any questions, please send them through now. We do have a few minutes before Eric is starting his session on the other track. You can find the link in there. Just give everyone a few moments to get them all in. I don't see any recent ones. I think we're pretty good. Again, Edwin, you have where they can find you on social, right? Just in case.
Yep.
Perfect.
Twitter, LinkedIn, feel free to connect with me.
Amazing. And again, thank you so much for this awesome session. Like we always are very thankful to have an awesome lineup of speakers, but this year we're just so thrilled with everyone that's come on board and given their time and effort. So thank you again. And thank you everyone in the chat for being with us all day today. That's awesome. I'm going to just link again where you can join the DBA track for the final session from Eric. But if we're all done, I think we're good to wrap up here. Yep. Thank you.
Great work, Edwin. I use Docker containers all the time in my demos, and I've been doing it for the last year. And just watching your session, it just kind of points out just how little I know about Docker containers, even though I use them successfully for over a year now. It's like, wow, thank God I haven't run into any of these problems before. Great job, man.
It's interesting you say that, because I was in the same boat as you until Apress approached me and said, why don't you write a book on this? I'm like, man, I knew 10% of what I just knew back then. And the entire year of writing the book, I'm like, man, I wish I knew this back then.
Yep.
Sweet.
Good job, man.
So do I just stop sharing?
Sure. Yep, thanks for staying up so late for us. We really appreciate it, my man.
Dude, it's morning for me. I'm up awake.
You're up and ready to go for the day, huh?
Yep, I'm just getting started, 6:30 in the morning.
All right. Oh.
And I'm going to hop in on the other stream. Hey, thanks, Aaron. Really appreciate your help on this.
Absolutely. And hope you get back to this side of the planet as soon as you can and safely. So,
Well, that's the goal. The goal is to be there first thing June. That is the goal. If things work out the way we wanted to, hopefully first week of June we're there. And I think the Canadian government is forcing a 2-week self quarantine. So by the time we get there, it's a 2-week quarantine, and that pretty much sums up how we're going to spend the next couple of weeks.
yeah. Yep. Lovely. Well,
All right. Thank you. I'm going to switch over to the other stream.
Thank you so much. Awesome. And thank you. And yeah, everyone, if you just keep an eye on the chat, you'll see that I'm linking again where you can watch our last session of May 2020 GroupBy.